At the unit circle here in section 3, before we get to the actual circle itself, a unit circle by definition is a circle that has a radius of 1. So the radius is 1, then the value of sine, cosine, tangent, and reciprocal functions can be simplified, and what it amounts to is our unit circle is going to contain those multiples of a 45, a 30, or a 60-degree angle, as we saw with some of our radian measure. So here's what we're saying. In a normal situation, sine of theta equals y over r. Well, if our radius, or our r, is 1, our sine equals y over 1, or just y. So on a coordinate plane, the sine is the same thing as the y coordinate if we're on a unit circle. So there's a key statement there, on a unit circle. If cosine is typically x over r, and we're on a unit circle, that means we know our radius is 1, so our cosine is the x value. So as we go to set up our unit circle here in just a minute, our x, y ordered pair are going to represent the sine and the cosine values. Cosine for x and the sine for y. Because we're on a unit circle, we're assuming or saying we have a radius of 1 on that circle. And then on that unit circle, or on that circle period, we're going to have, as I've already mentioned, multiples of our 30, our 45, or our 60-degree angles, or in terms of radians, that would be pi over 3, pi over 4, and pi over 6. So we're talking, 120, 135, 150, 180, 210, and so on when I say multiples. So 30, 60, 120, 150, 210, and so forth. Same thing with 45 and 60. So we have those angles that we'll use on our unit circle. So here is what our unit circle is going to look like. Here's a blank one anyway. I'm going to go through here and fill in some of our angles to begin with. We're going to start here with 0 degrees, or 0 radians. That's the same thing as 360 degrees, or 2 pi radians. Up here I'm going to go 90 degrees, which is pi over 2 radians. We'll go with 180 degrees here, which is just pi radians. And trying to fit this in down here at the bottom, we have 270 degrees, which is 3 pi over 2 radians. Since we're on a unit circle, we know from here all over to here, we've gone over 1 unit. That would be the radius of our circle. From the center out to this point is 1. We've gone up 0, so there's our radius. Going to the left, we've gone over 1, negative 1, and down, or up or down 0. If we slide to the top here, we've gone over 0, but up 1. And if we slide down to the bottom, we've gone over 0, but down 1. Okay, radius is 1, positive in these two directions, negative on the x-axis, negative down on the y-axis. So there's our start with our angles. Now with that being said, because we're on a unit circle, this 1 value here represents the cosine. Cosine of 0 degrees, or cosine 360 degrees, is 1. Cosine of 0 radians, cosine 2 pi radians is 1. Sine of 2 pi is 0. Sine is the y-coordinate. Along with those, we're going to go ahead and put the tangent in there as well. Tangent we know is y over x, so here tangent is 0. Here tangent is also 0. We'll start here at the bottom. Here tangent, I'm going to slide down a little bit farther, see if I can squeeze it in down here at the bottom. Tangent is y over x, negative 1 over 0, or tangent is undefined at 270. And as we move up here, tangent is also undefined at 90 degrees. So there's our start. Let's go back here and let's say we'll start out with our 30-degree angle. That's the same thing as pi over 6. Now, if we were to take this and go straight down and make our reference angle, we'd have a right angle right here. That would give us a 30, a 60-90 triangle. We know the ratio of those sides are 1, square root of 3, and 2. Now, as we've talked about with our triangles, those ratios stay the same regardless of the size of the triangle. So even though we've said previously our hypotenuse, our radius is 1, we're going to translate that into an ordered pair, and it would simplify down to have the same ratio. So taking a look at this, cosine is our x-coordinate. Cosine is adjacent over hypotenuse, or x over r. which is square root of 3 over 2. Sine is opposite over hypotenuse, or y over r, which is 1/2. And the tangent is equal to the opposite over adjacent, which is 1 over square root of 3, or if we simplify that by rationalizing the denominator, we get square root of 3 over 3. So there's our ordered pair. I'm going to get rid of this so we can clean it up a little bit. But we have our ordered pair there to designate our sine, our cosine, and we filled in with a tangent to find those three trig functions. And if we have those three trig functions, then we can go ahead and find our reciprocals, cosecant, secant, and cotangent as well. If we move over or continue on here, we've worked with these, I'll say, multiples of angles previously. Our curve is symmetric about the y-axis. So if I were to fold this thing along the y-axis here, this ordered pair would be the same thing over here. So the first thing I'm going to do is fill in the fact that this is 150 degrees, which is 5 pi over 6 radians. Now, as I just mentioned, this ordered pair, square root of 3 over 2 and 1/2, will be the same ordered pair we have over here with the same distance over, the same distance up. The only difference is we're in the second quadrant, so in the second quadrant, our x is negative. And since x is negative in the second quadrant, that means tangent is also negative, so we have negative square root of 3 over 3 for our tangent. So once again, we have labeled our x and y ordered pair, which is also our cosine and our sine, along with our tangent. So we have our three basic functions, and we can use that to find the other three. If we were to fold this unit circle down, it's also symmetric about the x-axis, so this ordered pair would wind up being plotted right here, and this ordered pair would be plotted right here. So we'd have the same ordered pair, just different signs in front of those. But let's start out by saying this is 210 degrees, which is 7 pi over 6 radians. Now, as I mentioned, our ordered pair is the same, so we have negative square root of 3 over 2. Since we're in the third quadrant, the y is also negative, so negative 1/2. And because both x and y are negative, that means our tangent is positive, square root of 3 over 3. One more time here in our fourth quadrant, folding this down, first of all, we'd have 330 degrees, which is 11 pi over 6 radians. Same ordered pair here, because we're in the fourth quadrant, the x is positive and the y is negative. And since x is positive and y is negative, that means our tangent is negative, so it's negative square root of 3 over 3. So you can see those angles are all based off of that ordered pair in the first quadrant, square root of 3 over 2. They follow just changing the operations or the signs from one quadrant to the next. Let's move on and we'll do the 45-degree angle next. That's the middle angle here, so 45 degrees, which I hope we all know is pi over 4. Now, if I went through the same idea and came straight down here, I'd have a 45, 45, 90 triangle with 1, 1, and square root of 2 as my two sides of my hypotenuse. If we found the cosine, cosine is adjacent over hypotenuse, or 1 over square root of 2, which as a fraction simplifies to be square root of 2 over 2. Sine would be opposite over hypotenuse, which would also be 1 over square root of 2, which by rationalizing the denominator would also get us square root of 2 over 2. And then because tangent is this divided by this, or opposite over adjacent, tangent is 1. Okay, so very quickly, by finding the sine and cosine, since we're on a unit circle, that ratio is simplified down to be square root of 2 over 2 and square root of 2 over 2, and our tangent is 1. And we have that same set of multiples from one quadrant to the next. So we move to the second quadrant, we have 135 degrees, which is 3 pi over 4. Same ordered pair, except the x is negative because we're in the second quadrant. And because x is negative, that means tangent is also negative. So tangent is a negative 1. So in the second quadrant, 3 pi over 4 is 135 degrees. Ordered pair is negative square root of 2 over 2 and square root of 2 over 2, which means cosine is negative square root of 2 over 2, sine is square root of 2 over 2, and tangent is negative 1. As we've already mentioned, we're working with our 30-degree angle. Our curve is symmetric, so we have the same ordered pairs down here. We'll start out by labeling this as a 225-degree angle, which is 5 pi over 4 radians. As I mentioned, same ordered pair, so negative square root of 2 over 2 and negative square root of 2 over 2. Both are negative since we're in quadrant number 3. And since both are negative in quadrant 3, our tangent is a positive. And in quadrant 4, we have 315 degrees, which is 7 pi over 4 radians. Same ordered pair, the x is positive because we're in quadrant 4, the y is negative, and that means the tangent follows to be a negative as well. So again, 3 other angles identified based off of the one angle in the first quadrant. Our last angle to complete this unit circle is a 60-degree angle. That is pi over 3 radians. And if I applied the same idea here, I'd come straight down. I have my right angle. Opposite the 60 is square root of 3. Opposite the 30 is 1. And the hypotenuse is 2. Again, our ratios will simplify down to be the same values regardless of the size of the triangle. So we'll start here generically. Cosine is adjacent over hypotenuse, or x over r, which is 1/2. Sine is opposite over hypotenuse, which is square root of 3 over 2. And tangent is adjacent over, or opposite over adjacent, which is square root of 3 over 1, or our tangent is square root of 3. So trying to clean that up a little bit so we don't have to have our diagram too cluttered here. We'll continue on to our second quadrant. Again, we have that family of graphs already started, so we have 120 degrees here, which is 2 pi over 3 radians. The ordered pair from here would transfer over, just the x would be negative. So we have negative 1/2 and square root of 3 over 2. And since we're in the second quadrant, the x being negative, the y being positive, our tangent is going to be negative, so our tangent is negative square root of 3. And we have 2 more to fill out. We're going down here to quadrant number 3. We have a 240-degree angle, which is 4 pi over 3 radians. Same ordered pair, so I have a negative 1/2. X is negative in quadrant 3. Y is also negative in quadrant 3, so negative square root of 3 over 2. And because both x and y are negative, our tangent is positive, so we have a positive square root of 3 for our tangent of 240 degrees. And our last angle here to complete our unit circle is 300 degrees, which is 5 pi over 3 radians. Ordered pair, my x of 1/2 is positive. We're down on the y, so my y is negative, negative square root of 3 over 2. And my tangent then, negative y over positive x, is going to be a negative square root of 3. So by filling out this unit circle, we now have sine, cosine, tangent defined for all of these angles and also for coterminal angles, in addition to being able to find secant, cosecant, and cotangent because they are reciprocal functions. Up here, if we wanted to find cosecant, cosecant reciprocal sine, sine's 1/2, and cosecant is 2 over 1, or just 2. And that, again, kind of completes our unit circle. We'll now use that to answer some questions back here on our original note packet. So I'm going to slide down here. It says find all the positive and negative numerals in the interval from negative 2 pi to positive 2 pi. So that means basically a positive and a negative angle measured in radians because of the 2 pi and negative 2 pi with our coordinates in negative square root of 3 over 2 and 1/2. So I'm going to pull our unit circle back up here. Before I do that, I'm going to point out that x is negative in quadrants 2 and 3. Our y is positive, so it's positive in quadrant 2. So we're looking for our angle in quadrant 2. So in quadrant 2, you can see right here, we find that ordered pair, negative square root of 3 over 2 and 1/2. So if I measure that angle in standard position, that's 5 pi over 6. If I measure that angle in clockwise direction, there's our negative angle, so it's negative 210 degrees, or negative 7 pi over 6. So our two answers then are 5 pi over 6 and negative 7 pi over 6. One positive, one negative value. One that goes from 0 to a positive 2 pi, which are 5 pi over 6. One that goes from 0 to negative 2 pi, which are negative 7 pi over 6. That's just reading that point right off the unit circle. Oh, let's move on and see what we have next. Find the values of the 6 trig function for point S on the unit circle. Here's a key statement for us with our coordinates of 0.8 and negative 0.6. Since we're on the unit circle, we can jump right to the fact that the sine is the y value. So our sine is simply negative 0.6. Our cosine, because we're on the unit circle, is the x value, or 0.8. Our tangent is the y over the x, so 0.6, negative 0.6 over 0.8. Can't have fractions as part of our simplified, or can't have decimals as part of our simplified fraction. So I move this decimal place over 1 on each spot. I have 6 over 8, or a fraction of 3/4. Our reciprocal functions, cosecant of s is the reciprocal, so 1 over negative 0.6. Again, if I move the decimal place over one spot, I have 10 over 6, which is negative 5/3. Secant s would be 1 over 0.8. Moving it over, I'd 10 over 8, or 5/4. And we've already moved it over for tangent, so cotangent is a little bit easier. Reciprocal of negative 3/4 is negative 4/3. For the next example, we're going back to our unit circle. Cosine of pi over 3. So I'm going to go to my unit circle here. Pi over 3 is right here. The cosine is the x value, so it's positive 1/2. I'll make that substitution 1/2. Notice that cosine is being squared, so I squared that. Minus the sine of 3 pi over 2. So I'm going to go back down here to 3 pi over 2, which is down here at 270 degrees. The sine is the y coordinate, so it's negative 1. Making that substitution then, I have negative 1. And I'm going back to pi over 3 for the sine value, so back to pi over 3. And I'm going to slide up for that. So sine of pi over 3 is right here. Sine is the y coordinate, so it's square root of 3 over 2. And notice that value is being squared. So now all we have left to do is that math work. 1/2 squared is 1/4. I'll leave the negative 1 here while I go ahead and square this. Square root of 3 over 2 squared is 3/4, which gives me 1/4 minus a negative is plus, and 1 times 3/4 is just 3/4, and 1/4 plus 3/4 is 1. So again, just pulling those values straight off of the unit circle. A little algebra involved in these next two. Sine squared plus cosine squared equals 1 to solve, given the fact that sine equals square root of 3 over 2. So we're going to take this value and plug it in here and pretend that we didn't have our unit circle in front of us. We had to find cosine of pi over 3. So we have square root of 3 over 2 squared plus cosine squared equals 1. Square root of 3 over 2 squared is 3/4 plus cosine squared equals 1. I'll subtract 3/4 from both sides. So now cosine squared s equals 1/4. Since I want to find the cosine, not the cosine squared, I'll take the square root of both sides. So I'm going to take that up to here, and that will say that cosine equals plus or minus. I'll go in a couple of steps here. When I have a fraction underneath the radical, I can write those two separate fractions. So that winds up being plus or minus the square root of 1 is 1, the square root of 4 is 2, and because we're trying to find the cosine of pi over 3, that's the same thing as the cosine of 60 degrees. 60 degrees in quadrant 1, so our cosine is positive in quadrant 1. So cosine of pi over 3 equals 1/2, and we could verify that off our unit circle right here. You can see cosine equals 1/2. Our next problem is not going to be on the unit circle. Cosine of s equals negative 2/3. We're between, s is between pi over 2 and pi, which tells us we're in quadrant 2, between 90 and 180. We're going to find the tangent of s. So I'm going to take this negative 2/3 and plug it in for cosine in this identity, and we'll say sine squared s plus negative 2/3 squared equals 1. And now we'll do some algebra to solve. Sine squared s, negative 2/3 squared is 4/9 equals 1, 4/9. Subtracting 4/9 from both sides, I get sine squared equals 5/9. I'll take the square root of both sides. So sine square, or sine s, so I took the square root, get rid of that square root squared sign, equals plus or minus the square root of 5 over the square root of 9. Well, the square root of 9 is 3, so I'm going to jump straight to that step. Our final piece here, to at least solve for sine anyway, is knowing whether it's positive or negative. I go back up to here. S, or our angle, falls between pi over 2 and pi, which is in quadrant 2. Sine is y over r. Y is positive in quadrant 2, so it's a positive square root of 5 over 3. So then to find the tangent, tangent is y over x. Well, since we're on a unit circle, y is the same thing as the sine value, x is the same thing as the cosine value. We have those values. Sine we just found to be square root of 5 over 3, and cosine we found to be, or we were given to be negative 2/3. I did it again. Square root of 5 over 3 divided by negative 2/3. And we all know we divide with fractions, we multiply by the reciprocal. So square root of 5 over 3 multiplied by negative 3/2. I hope we'd all agree that the 3's will cross cancel, and our value is negative square root of 5 over 3 for the tangent of S. Okay, so we zipped through the algebra involved there. Just another example of our identities and so using some of our trig functions. Let's try again here. We'll zip through both of these as well. Find the 6 trig functions of S at a point on the unit circle with a given coordinates, negative 3/5 and 4/5. Because of that statement on a unit circle, the sine is simply the y-coordinate. The cosine is simply the x-coordinate. The tangent, as we just discovered, is simply y over x, so 4/5 divided by negative 3/5, or negative 4/3. Our cosecant is reciprocal, so 5/4. Our secant is reciprocal, so negative 5/3. And our cotangent is reciprocal, negative 3/4. I'm going to zip through one more of those. B says 8/17 and 15/17. We're still on the unit circle. So our sine is still the y-coordinate. Our cosine is still the x-coordinate. Our tangent is still y divided by x. And 15/17 divided by 8/17 is 15/8. Cosecant is reciprocal, 17/15. Secant is reciprocal, 17/8. And cotangent reciprocal, 8/15. So zipping through those, they were fairly easy because of our ordered pair and the fact, the statement that was made that we were on a unit circle. Use our calculator to approximate. So I wrote this up here several times previously. I'm going to write it off to the side here. The sine of an angle equals the ratio. So notice here, if I put an x on the end of this, that now matches up with this equation. So the 0.6019 is an angle. Because it doesn't have a degree symbol on it, that means it's an angle in radians. So with our calculator, the first thing we want to do is make sure we're in radian mode. And I go down here and highlight radians in mode. I'll clear out of that, and now I just want to find the sine of that. So the sine of 0.6019 is 0.5662. So here we have 0.5662 as our answer. Same thing applies here. I'll go ahead and put an equal to x on the end of it just so it matches up. The negative 1.1519 is an angle measured in radians. So I simply type in the cosine of negative 1.1519. Notice here we get 0.4068 from our calculator. And one more time, tangent equals x. Again, 4.0203 is a radian measure. So the tangent of 4.0203 gives us a value of 1.20648. Okay, so there's our work with the calculator and finding those values from a radian mode. Our last few here, find the exact value of s in the given interval that has a given circular functional value. So first of all, our interval is pi over 2 to pi. That's from 90 to 1/8, so that's in quadrant number 2. Sine is 1/2, so I'm going to go to my unit circle and look at quadrant 2. Where does sine equal 1/2? Sine is my y value. Square root of 3 over 2, square root of 2 over 2, so here's where it equals 1/2. Notice our angle here wants it in radian measure because it was between pi over 2 and pi, so our angle is 5 pi over 6. That's the only angle that falls in that interval as a positive angle. Let's go ahead and try a couple more of those. Tangent of s equals square root of 3 between pi and 3 pi over 2. That would put us in quadrant 3. So I'm going to go to my unit circle and find out where does tangent equal square root of 3 at. And if I slide down here in quadrant number 3, tangent equals square root of 3 right here, and that is at 4 pi over 3 radians. And finally, letter C, between 0 and 2 pi, so an entire revolution around, sine s equals negative square root of 3 over 2. Well, sine is going to be negative in quadrants 3 and in quadrants 4. Quadrant 4. So we're going to find two answers here, one in quadrant 3 and one in quadrant 4, where sine equals negative square root of 3 over 2, or y equals negative square root of 3 over 2. So you can see y equals negative square root of 3 over 2 right here at 4 pi over 3, and equals negative square root of 3 over 2 right here with 5 pi over 3. So those are both our answers, 4 pi over 3 and 5 pi over 3 are two answers for that case. And there's our opening look at the unit circle.